Guys, welcome to the Python Livestream in Jenko. My name is Jay Patel, and as you guys could see, you see me from my Jenko videos. I'm the Python instructor for Jenko. So this livestream is just going to get you a little more familiar with the videos we learned. I'll just go through some of the basics of Python programming. We're going to go through some Turtle. I know you guys all like the Turtle videos. We'll go through some of that by doing some programming in Turtle. We'll talk about some arithmetic operators, and we're also going to be talking about some functions. And in this one, I'm also going to add something else that we didn't talk about the video, but you guys will catch on as I do it. So it's something on files. So we're going to talk about that towards the end as well. So let's just jump into this right now. All right, so I know you guys all like the Turtle videos, so we're going to start with some Turtle problems. Let's just go through some basic shapes. So how do we do Turtle, right? Turtle is a module in Python. It's a built-in module that we use in Python. So the way we use modules in Python is we import them, right? So in this case, when we ever want to do Turtle, we want to import Turtle. So let's just type in import Turtle, right? So that's our Turtle module. Now we have to create the screen. So screen is going to be, and we're going to set a variable s equal to Turtle dot screen. And we're also going to create a Turtle. So I'm going to name it T, but you can name it whatever you want. And we're going to set that equal to Turtle equals Turtle. Okay, so that's the basic setup when you ever start a Turtle problem. And if you want a little recap of this, we had this in lesson 7 on the Turtle graphics. So you could go back and watch that video as well. Okay, so now let's see what we want to create. We could create basic geometric shapes. So let's start with like maybe drawing a triangle, right? So how do we draw a triangle? So we have to command the Turtle, which is the pen, just like the pen on your paper. We gotta command that to draw a triangle. So the way we do it is we take the variable Turtle we set the T, right? So we say T dot. Remember, the dot is a command. It tells Turtle what to do. So I'm going to tell the Turtle I want to go forward, and I want to go forward 100, right? So that's going to tell the Turtle to move forward 100. Then now we want to do the turn, right? So on a triangle. So whenever we talk about geometric shapes, we talk about how they turn on angles, right? So in a full circle, we have to think about it's a 360, right? So, and we have to divide that by the number of sides a triangle has. So a triangle has 3 sides. So what we have to do is divide 360, take 360 and divide by 3. So if we do that right now on the calculator, take 360, and I'll show you right now. 360, and we divide that by 3. 120. So every time we want to turn 120. So that's what we're going to do. So we're going to tell the Turtle to turn right, and we're going to tell it to turn 120. Now that's going to complete one side of it. So now we got to do this. We have to repeat this 2 more times because we have to for the full triangle. So again, I'm going to go forward 100 after that. And I'm going to turn right again, I think, right? So I'm going to be turning right, and I'm going to turn right again 120. And I'm going to go forward 100. And again, I'm going to turn right 120. And that should do it. But let's see what happens when we run this. And turn right 120. Now do the Turtle. Let me just take this into idle. Save it as a Turtle. have a little error right here. Let's see what that is. Functional image. Okay. Still giving an error here. Sorry, a little technical difficulties. Don't know why it's not working. Okay, there we go. I don't know why that was giving me right there. Something wacky. But there we go. You see we drew the triangle, so it works. It's a little more inefficient because it's so annoying to keep repeating doing this every single time we have to do it, right? We have to keep writing the same thing over and over and over. So it just becomes the code just becomes so lengthy. So that's why we talked about loops, right? So we could do this using loops and it'll be like maybe from this many lines of code to maybe like 2-3 lines of code. So let's do that right now. So if you want to still draw the triangle, we could use the for loop here, right? So let's say for I in range, and we want to repeat this how many times? 3, right? So let's say for I in range 3. And we want to just go forward 100 to draw this triangle. And we want to turn right 90. No, sorry, 120. And this should still draw the triangle without the same result. So as you can see, it's more efficient using the loop, right? Than without the loop, right? So if you have anything lengthy, any code that you have to keep doing repeating the same thing over and over like we did here, it's better to use the loop, the for loop, and just write it like 2 times only instead of 5-6 times. But yeah, we could draw that, and we could draw a couple other geometric shapes. So if we wanted to change this and we wanted to draw a square, right? And now a square, we have 4 sides, so you just take 360, divide that by 4. And that will get us 90. So let's do that. So we do 4, right? Because square has 4 sides. So for I in range 4, we go t dot forward 100 and t dot right 90. And that should draw us the square. So it's pretty straightforward, and I think it's pretty fun in Python that we use the total. I know a lot of you like the total graphics video, so it's a good. It was just a fun way to start this live stream up with using total a little bit. Again, total is almost like what we talked about in classes. So this is what took us from the. I used this as an example. So when we did classes, it was going to be much more easy for you to understand, because total works the same way as how we make our own class in Python. So I want to go through a couple other problems, like arithmetic problems. So we could use by calculating areas of a triangle and area of a square, etc. Right? So what we have to do is let's do that right now. So let's have a problem, right? We want to set up a we want the user to enter an input, right? And we want to enter a radius, right? To calculate an area of a circle. So we have to prompt the user to enter in a radius. So let's start with that. So let's say let's set a variable called radius, or let's just do R for radius. And we tell the user to do, we say int, because it's a number, so we have to always put the int data type in front of this input, and we just tell the user enter a radius. So this will tell the Python will tell the computer user to enter a radius that you want to enter for this formula. Now we have to create the formula, right? So what is an area of a circle? So let's set a variable called area of circle. And let's set that equal to pi. So an area, the formula for a circle is pi. So we can say 3.14 times the radius, right? So we're going to use the R because we set R as the radius. And we're going to raise that to the second power. So that's the formula for an area of a circle. And now at the end, we just want to tell Python print area of circle. So now it should print it once we enter the radius. So run it, it's telling us, look, it's telling us the users to enter a radius. So let's enter 1 as the radius. And then it calculates it, 3.14. And when we put 1 as the radius and we multiply this, it will get 3.14. So we know the formula works. But here's the catch. If we want to enter a decimal, this will actually give us an error. So if I want to enter 1.1, it's going to give us an error. And the reason we got the error is we got the value error. And we got this because this is an int type, right? And when you do 1.14, this is not an integer. This is a float. So in that case, we will have to change the int right here to a float. And that will make it work for either a whole number or a decimal. So let's run this again. Let's enter 1.1. And now you got an actual calculation. This is probably not the most accurate answer. I mean, there could be because we're using this 3.14 and not pi, the full pi. So this is probably close to the exact answer. If you wanted to use pi, we could just use the math in the math module. And the math module is we just have to import it. So let's do that. I could just do this too. It'll be more accurate. So import math. And instead of 3.14 right here, we could use math.pi. And now that will give us a more accurate answer. So let's do 1.1 for the radius. And this is the exact answer if the radius is 1.1. So when we calculate an area of a circle and we use 1.1 as the radius, the area of a circle will be 3.8 and a bunch of decimals, a bunch of numbers after the decimal point. So we could use a lot of the math modules to calculate formulas, right? So this is like from basic geometry class, right? You could use Python to calculate areas of a geometric shape. In this case, we did an area of a circle. So I thought it was pretty cool doing this, right? So this is a pretty good way for computer scientists to calculate areas of a circle, triangle, square, etc. But we could even write this as a function, right? So if you want, so if we talk about functions, we could do this. Def, we want to find the area. We pass in the parameter, which is the radius, and we set the radius equal. We write the formula for radius. So the radius. No, we write the formula for area of a circle, right? So area of circle, and we could say math.pi. I forgot to import it, so let me import it right now. Math module again. Math.pi times the radius, so we pass that as a parameter and raise that to the second power. And at the end, we want to return the area of a circle. And we want to, then we're going to say print area, and we're going to pass in the radius 1. And it should still give us an answer. Yeah, see, it gave us the 3.14. So we can use this as using as a function as well. And it actually took the code down a little down too from a few lines. So it made it more efficient with using the function method, but either way it works. Functions are a powerful tool in Python, right? Or in any programming language, right? Java, C++, we use functions a lot. So functions is a more efficient way to do this too, especially to calculate this. And in this case, you don't have to even change any, you can use anything. You can even use a decimal point and it will still calculate it like that. See, when we put 1.1, when we put 1.1, we still got the answer 3.8. So it's a good way to do this. I mean, we calculated pretty well, right, with using the functions, and without the function, it's still calculated. So this is Python is a great tool to calculate geometric shapes. And I'm sure if any of you use Java, I'm sure that you could do the same thing in Java as well. So that's just a general key in computer science, that you could still calculate mathematical equations in your program, and it'll still, the computer could calculate quicker than when a human can. So that's why it's a good, powerful tool to use to know this. Maybe you can even use this as a simple for the fun of it. So now we went through some of the basic stuff. I want to go through some word problems. So I have 2 problems here right now set up. One of them is on classes, and one of them is on files. And this one we didn't really talk about in the GenCode videos, but I'll explain it as I go. And maybe in future lessons, I will go more deeper into files as well. This was a little more tricky, so I didn't really want to go into the files in the GenCode videos. But now, once you guys become more Python experts, we could talk about files more now. But let's go to this problem first. Let's talk about classes, right? So this is a class problem, and I'll read the problem right now. So it tells us, write a definition line for a class named state and a 1-line doc string that describes what a state is. Write the definitions of the following methods, functions in the code for the class. So these are the methods that we have to write in our class. And it tells us we want to use the class name state. So let's do that right now. I set the file, but you have to save it as state.py because this is your class. To do a class is simple. We say class state, right? So like class state, right? And now we have to write a 1-line doc string of what a state is. So that's just basically a comment in quotes. So a state is a land in a specific country, just like New Jersey, and just like the New Jersey is in the United States, California is in the United States, right? It's a state is just a land in a country. So that's what we're going to write as a docstring. A state is a land in a specific country. Now, what it tells us to do is in our first method is write an initialization method. And the initialization method should take a string parameter name and assign its a variable name of the state being created. It also tells us we need to create a list variable called universities for the state being created and initialize it to an empty list. So let's do that right now. So when we do classes, I always tell you the first method in a class in Python is always the initialization. So this is how we write it. Def __ int, and we take in self. Self is the first thing we always take in as the in a class, right? Any parameter, self is always going to be the first parameter. And it tells us to take a parameter name, right? So we're going to take in the parameter name, and we're going to, so now we're going to say self, because it's telling us now we need to take the name and assign its variable name of the state being created. So this is how we do it. We say self name is assigned to name, and we take in self universities, right? And we have to create an empty list. So that's what it also told us to do. So we created an empty list, right? Universities. So that takes care of the first part of the problem. This is always going to be the first method in a class problem. You're going to always have to do the initialization method, and that's how you do it. So the second part of this problem is saying a method, now you have to create a method named add university. So let's create a method. So that's, we're going to say f add university, right? That's the function's name. And it's going to take in self, always, that's the first parameter. And what else it's going to take? It's going to take a parameter called name and university. And this method is telling us we need to, this method should take a name of the university as a string parameter and add it to the list of universities for that name. So we're going to do self.universities append university. And I don't need that parameter. And that's it. That takes care of the second part of this problem. So we're done with that method. Now we create the last method. And that's called is homework. So let's call that is homework. Takes itself, and this should take in a university. And we want to see if that university is in that specific state. So I said, let's say Princeton, right? Princeton is in New Jersey. I want to say if Princeton is in New Jersey, return true. Otherwise, if Princeton is not in New Jersey, return false. So we could say if university not in self, if you actually we could say if university in self dot universities, return true, else return false, right? And that takes care of that method as well. So that was the first part. So now we could test this, right? And the next problem question 11b is showing that assume that the code of for the state for the class state question A has been saved as a file named state.py, which we saved it as that, right? We saved the file Python file as state.py, and write a code that performs the following task. Each task takes one line, right? So in this case, we could do the import. So first thing we have to do to test this is we have to import. So just like total, we have to import state, right? Because that is our file's name, right? That's the module we created. So this is how the total thing related back to this, right? Total was something to get you into making your own module. So state is the module we created in Python. Let's see. It says so we did that. We imported the class state. Now we got to create a constructor. So let's say we set New Jersey equal, right? We got create a state and let's pass in New Jersey as that. So this is like the total. This is like the T that I created in total. New Jersey is that. So we say New Jersey. So now to test all this, we have to just say this New Jersey dot, right? The dot tells us commands it what to do. So let's see, create a state name New Jersey. So we did that. So let's add university. So let's take in that method first. So we say New Jersey dot add university. And it tells us we want to add the university NJIT and Princeton. So we're going to say, let's do that first, NJIT. And the next one, the same method, add university. And we add Princeton. There, so we added that. So that takes care of that part. And now we want to check whether New Jersey is the home of MIT and print that result. So we could say New Jersey. Now we take this last method is home of, right? So is home of, right? And we pass in that parameter MIT. And we want to print that, right? So it's just print the result. So say print, right? Is, and we say is New Jersey, is New Jersey the home of MIT? And what's that? Oh, sorry, that doesn't have to be there. Because I didn't put state. Okay. Now this should actually run. No. Oh, because I didn't do that. That should take care of it. Sorry. Module needs state. Yeah, that was just capitalization error. So as you can see, Python is always case sensitive, right? If I did just capital S, it's giving me an error. So we have to make sure it's lowercase, and I had an error right up there. But as you can see, it's giving us false, right? New Jersey is not home of MIT, so it's giving us false. But if I were to change this and change MIT to NJT and change this is New Jersey home NJT, this should print out true. It printed out true. So that's how we use classes. See, we create a class. So we create a class called state, right? We create an initialization method, passing the parameter self and name. And then we took in self.name equals name. And we took in the universities and created an empty list, right? And then in this method, we appended, anytime we saw the university, we appended that to the list, right? When we wanted to add it. And here we added NJIT and Princeton to that list. And then we used the last function, right? And the last method called is home of, right? So if the university is inside that list, we turn it true. If it's not in that list, we turn false. And as you see, when we added to that list was NJIT and Princeton. So when we passed in NJIT is home of, right? It gave us true because NJT is in New Jersey, right? But if we change that to MIT, right, which is in Massachusetts, right, it's not in New Jersey, so it's the home of Massachusetts. So this will actually return false, right? So it's a good way to organize your code. That's what classes are. That's the main purpose of a class, is to organize all the code and your code. So each method, each method has its own functionality in it, and that's a good way. And you can see it's so neat to look at this code, right? When we look at everything under the class, we had the initialization method, we had the add university method, and the is home method, and we tested it by using the import. And we tested by passing in each of the parameters here. So that took care of that first problem. And that was a little recap on the classes. And if you have to go back, I see we did a lesson in classes in the GenCode videos. And now the final thing I want to talk about in this live stream is the files, right? So I think in the GenCode videos, we did not talk about files at all, but that's because it's a more complex topic to talk about. I didn't really want to talk about it since that was just the introductory course of it. But in future videos, I will dig deep into files. But right now, let me just give you a little preview of how to do a file problem. So right here, we have a problem that says write a function named line stats, and the function line stats take in 3 parameters, right? It takes an in file, so that is a string, that is the name of the input file. It takes an out file, a string that is the name of the output file, and it takes a threshold, which is an integer that is the length above which a word is considered significant. So the function linestack should read and analyze each of the lines in the input file and write two statistics separated by a space about the line to a corresponding line of the output file. And the two statistics for each of the lines are the number of words, right, in the line, and the number of distinct significant words. So the words that are longer than the threshold. So if you look at the example right here, we have a file right here, right? The input file that says, yes, some are red and some are blue, some are old and some are new, right? And that's the in file, right? This is what the result should produce, 8271 in the out file when we run the code. So let's see why these are the results. So if you look at the first line, yes, some are red and some are blue, have 8 words, right? So if you count them, 1, 2, 3, 4, 5, 6, 7, 8, 8 words. And that meets the first part of what we need to complete in this problem, the number of words in that line. And then the number of distinct significant words that are bigger than the threshold. So the threshold is 3. So find words that are bigger than 3. So there's only 2, right? It printed out 2. So there's only 2 words in this first line that are bigger than 3. Some, which has 4 characters, and some again, which has 4 characters. And then the second line, it has 7 words, right? So it printed out 7, 1, 2, 3, 4, 5, 6, 7. And then we have 1 word that is bigger than, and that had characters greater than 3. And that's some, which is 4 characters again. So let's oh, and it has some again here, but as you can see, it says distinct, right? So that means different, right? So some and some are 2 different words, right? They're not the same. Capital S is not the same as lowercase s. And the first line I made a mistake. It's some and blue. This sum doesn't count because it's only distinct words, right? So this is already 1 time, so this is a repeat, so this doesn't count. This is a repeat, so it only has 2 words actually. Some and blue in the first line that are bigger than 3, and it only has 1 word that is bigger than 3, which is some again. This one is not the same as that. Okay, so let's do this problem. So first things first is we write the function called linestack. So here's our function. It takes us 3 parameters: in file, out file, and threshold, right? Now, to any file, anytime you start a file program, you always have to open a file. So let's call this file called in file inf. We set aside that, say open, and we're gonna read to this file. So in file, and to read to a file, we just use the string or to read, and out file. We're gonna write to this file, so we gotta use the W here. So out file W. So it's gonna write to the file. And now we go to for line in F, and we're going to strip each of the lines. So let's say line is equal to line dot strip. This strips the spaces in the ends. That's what the strip function does. And we're going to say would are equal to line dot split, which splits each of the characters into individual, which takes each of the words, takes each of the characters in like it goes by character it goes by word instead of character. So we split on white spaces. Anywhere you see a space, split's going to space into individual. So it's going to turn this list of it's going to turn these strings, this one string, into a individual list. It's going to basically. And next thing we have to do is we go we create an empty list. Let's call this T. And now we go for each wood. So for wood in wood, so we're going to go through each of the woods. And it said right here, lowercase, right? It says input file contains only upper and lowercase letters. So we use the dot lower function here. So wood equals wood dot lower. And that should be it, right? Also set up a counter here, just 0. And I think it's yeah. Took no. So the counter is supposed to go actually up here. Set to 0. I think what I did here is so we have to write to this file, our file dot write, and it's gonna take the length. I think length of T, right? Yeah, string length of that, changing plus the space. And I think that's pretty much it, right? Okay. Now we can just go to the if else statement. If the length of the wood greater than special, right? So if it's bigger than special, we're going to do T dot right, append the wood. T not wood not in T. So wood is not T dot append the wood. And I think that's it for that. So now we have to write to that file. So we can say outf dot write, and we have to write the length of T, right? So we got to change this to a string. Remember, you have to always write this. You have to write it. I'll explain this when we actually do more of this, when we do actually talk about files a little bit more. It should be T. And we're gonna add a new line. So to do a new line, here every time you just do \n for that. And anytime we open a file, we have to close them. So we have to say inf.close and outf. And if you want to test this, you have to say if we have to do this. This is how we test it. If name is equal to line stats fish.tx, so you have to create a file called fish.txx as a string. I'm gonna type that's our in file that we're gonna write, that we're gonna read to. This is the out file that it's gonna create fish out txt. Make sure these are all in the same directory. Otherwise, it won't work. And special T. Let me change this path quickly. Edit career. We're gonna call this line. That's 2. No fish file, so we have to create that actually. So let me do that right now. So you can go into your notepad or whatever and just create a fish file. And the file that we're creating right now is called this. So let's say yes, some are red and some are blue, some are old, and some are new. I'm gonna save this as a save as fish.txt. Go into my directory. Copy that. Gonna go into the we add that now. Go back to the code. Okay, there we go. Now it should create a file called fish in our directory. Oh, and there we go. We created that file. Create 8271, but we should have this as a space here. So, yeah, so I created the file that result 8271, which is what the problem, which is what the output that we wanted, 8271. So that was a little touch on files. So I know there was maybe something that you guys didn't know that much, but we're gonna in future videos I will go deeper into files once we go into more advanced topics, but it was just a little preview I wanted to show you guys. So without that, I'm gonna say this is the end of the live stream. I'm assuming. So I hope you guys enjoyed it. I hope you guys learned something, and I hope you guys watched some of the past videos I made to explain some of this. So yeah, so have a wonderful day, and I'll see you soon.